Okay, I have behind me here 3 rotary tables, and they're all different from each other. I'm going to give you a way to set any rotary table, one method, and this one in particular has minutes on the dial. Maybe you don't want to use the minutes. You don't have to. So I'm going to put the camera in close, and we'll do this little guy first. Okay, now I know that the gear ratio for this rotary table is 36 turns of the dial to 1 revolution of the table. And there are 40 ticks on this dial. So the first thing we're going to do is find out the value of each tick. And we do that by, okay, if I went 1 turn with this dial, there would be 40 tick marks that went past the pointer right here. 40 tick marks, and I have to do that 36 times to make 1 revolution of this table. So you're going to multiply 36 times 40. And we get 1,440 ticks for 1 revolution of the table. Now, think about this for a second. Now, okay, 1 full turn of the table is 360 degrees. So we take 360 degrees and divide that by the number that we just got, which was, well, let me do that. I think it was 1,440. And we get 0.25 degrees. That's the value of each tick. It's 0.25 degrees. Okay. Now let's say you had, you wanted to divide, you had to drill 7 holes around in a circle. So 360 degrees divided by 7 gives you this number, 51.428 degrees. Okay. So you take this 51.428 degrees and divide that by the value of each tick, which we found to be 0.25. And you get 205.714 ticks. Okay, then you take that number and divide by, there's 40 ticks on the dial, so you divide by 40, and that gives you how many turns. So it's going to be 5 turns, and the 0.142928, we have to treat that differently. So we're just going to take the 5 and use that. We know we got to turn 5 turns. So the 0.1428, let's subtract the 5, minus 5, and we just have the 0.1428 now. And we multiply that number by the 40 ticks that are on the dial, and you get 5.741714 ticks. So we would turn 5 turns, 1, 2, 3, 4, 5, and then we're looking for 5.714 ticks. So 1, 2, 3, 4, 5.714. That's almost 3/4. So I'm just gonna kind of eye that right about there. And that's how you do that. Oh, and also for the next hole, you want to take your 51.428 degrees and just multiply by 2 because you're on the second hole. You get 102.857 degrees. And just do the same thing with that. And then your 51 point whatever it was degrees, multiply by 3 and do it again. That's just the way I recommend doing it. You can, of course, you can just count that many turns from where you're at, or however you want to do it. Okay, now I'm going to move on to the rotary table that has the minutes, right? And the vernier scale gives you 10 seconds for each movement. Okay, now this rotary table, the 0 is the pointer, and if I made 60 ticks go past the pointer, that's 60 ticks, and that is 1 degree. So those are minutes. Each tick is a minute. Okay, now I'm going to go another 60 degrees, another 60 ticks, and we're not going to think of that as another 60 ticks. We're going to call that 60 and another 60 is 120. So we're at 120 ticks plus another 60. What's that? 180. 180 ticks. And when we get to here, we want 1 full turn of the dial. And that's 240 ticks. Okay, and the gear ratio is 90 to 1. 90 turns of this dial for 1 turn of the table. So now the same thing again. We're going to find the value of each tick. So we do 90 to 1 gear ratio times 240 ticks per turn of the dial. And that's how many ticks will pass when the rotary table does 1 revolution. Okay, now you take same thing. 1 full turn of the table is 360 degrees divided by that answer that we just got, and we get the value of each tick in degrees. 0.01666 endlessly. Okay, now same thing. Let's say you had 360 degrees divided by 7. You get that weird number again. 51.428 degrees. Now, you divide this number That's how far you want to rotate for 1/7 of a turn. Divide this number by the value of each tick, which was 0.01666,666. Good enough. And you get 3,085.715 ticks you're going to have to go to, or go past, or land on that tick, however you say that. Okay, and there are 240 ticks on the dial, so you divide that number by 240, and that's how many turns you have to turn the dial. So again, we're going to use the whole number, the 12. We know we're going to turn the dial 12 turns, 12 revolutions. And then for the 0.857, we're going to treat that differently. So let's get the 12 out of there by subtracting it. And we just have the 0.857. And you multiply that number by the 240 ticks on the dial. And that's how many ticks. 205.715 ticks. So 12 turns, 205.715 ticks. And the other rotary table, I don't think we need to do that one. I think that one is what is it? 72 to 1 gear ratio. I believe that's what it is. Yeah, 72 to 1, and there are 150 ticks on the dial for that one. So I don't think we need to do it, but I'll just show it anyway. So we're talking about now this bigger rotary table underneath of the little guy. And there's the dial for it, and it's not lit. Anyway, I'll try to get a light on it. Yeah, that dial there, there's 150 ticks on that dial, and it's 72 to 1. So I think you get the idea.